Hello friends, welcome to Civil Engineering exam. Today we are going to see the problem related with soil mechanics in the topic of effective stress. So the problem is a 10-meter thick sand deposit overlays a bed of soft clay. The water table is 5 meters below the ground surface. Then if the sand above the water table has 45% of degree of saturation, then calculate the effective stress at the middle and bottom of the sand layer. Take E void ratio that is equal to 0.68 and specific gravity G equal to 2.65. Okay, so now we can draw the layers. So 10-meter thickness, the sand layer. So sand layer is overlays the soft clay. Okay, so here the soft clay, here is the sand layer. So this is the ground surface. So from the ground surface 5 meter below the ground surface there is a water table. Okay, so here is the water table. So here is 5 meter, here is 5 meter. Okay, so now we can find out the effective stress at the middle and the bottom of the sand layer. So middle layer is here and the bottom layer. Okay, so here we can take this one is A and here is A, here is B and B. Okay, so we have to find out A and B points. Okay, so next thing is here this degree of saturation S equal to 0.45, that is 45 percentage, and E equal to 0.68, then G equal to 2.65. Okay, so here also S equal to 1 because here is the water table. So in the water table the degree of saturation is 100 percentage. So then E equal to 0.68 and G equal to 2.65. Okay, so now we can find out the here is gamma 1 and here is gamma 2. Okay, so this is bulk unit weight, here is saturated unit weight. So this one is taken as H1, here taken as H2. So first thing we have to find out the gamma 1, gamma 2 values. So now the gamma 1, so gamma 1 equal to the formula G plus E into S into gamma W divided by 1 plus E. Okay, so now we can substitute. G is given, that is 2.65, plus E also given, that is 0.68. Then gamma 1, the degree of saturation is 0.45, that is 0.45. Okay, into gamma W value is 9.81 divided by 1 plus E, that is 1 plus 0.68. Okay, so solving this we got the value of 17.26 kilonewton per meter cube. So next thing is gamma 2 value. So gamma 2 equal to again the same formula G plus E into S into gamma W divided by 1 plus E. Okay, so now here you can substitute 2.65 plus 0.68 into 1. Okay, so here the degree of saturation is 1. So now we can put 1 into 9.81 divided by 1 plus 0.68. Okay, so solving this we got the value of 19.44 kilonewton per meter cube. Okay, so now we can easily find out the effective stress at the middle and the bottom of the layer. Okay, so now we can take the middle of the layer at AA. So at AA, sigma equal to total stress equal to gamma 1 into H1. Okay, so here we can take gamma 1 into H1 because this stress equal to load by area. Okay, so that is equal to kilonewton per meter square. So now we can put here, so gamma value, so that is in kilonewton per meter cube into the H value is in meter. So meter and meter cube will be cancelled, so the meter square will be there. So now kilonewton per meter square will be the answer. So that's why we are multiplied the unit weight into the height. Okay, so now we can take here, so the gamma 1 value is 17.62 into H1 value is 5. Okay, so solving this we got the value of 86.3 kilonewton per meter square. Okay, so next thing is mu. At the water table there is no water table above the water table, so now mu equal to 0. Then sigma dash effective stress is sigma minus mu, that is equal to 86.3 minus 0, that is equal to 86.3 kilonewton per meter square. Okay, so next thing is at BB. So now we can take the sigma value. So at BB there is a two layer is here. So there gamma 1 into H1 and gamma 2 into H2. So now we can take gamma 1 into H1 plus gamma 2 into H2. So that is equal to 17.62 into 5 again plus the gamma 2 value is 19.44 into 5. Okay, so solving this we got the value of 183.5 kilonewton per meter square. Okay, so next thing is mu value. So there is a water table here. So there is a water over here. So now we can take gamma W into H2. Okay, so now 9.81 gamma W into H2 value is 5. So we can solving this we got the value of 49.05 kilonewton per meter square. So next thing is sigma dash value. So now sigma minus mu. So that is total stress minus pore water pressure. So now 183.5 minus 49.05. Okay, so solving this we got the value of 134.45 kilonewton per meter square. Okay, so this is the effective stress at the middle of the layer and this is the effective stress at the bottom of the layer. So this is a method we can solve the problem. Again we will see next video. Thank you.